to another video. I'm your tutor and my name is Roland. In this video we'll be continuing with the trigonometric ratios in the Cartesian plane. If you haven't watched the previous video, please make sure to go and have a look, because it's just a quick revision on how the right-angled triangle works. Right, so let's look at this. We've got a line that starts at the origin and moves up towards a point diagonally. That point is called P, and it has the coordinates x and y. The x-axis is drawn in, and so is the y. And then we call that line, that diagonal one, R. Hey guys, welcome to another video. I'm your tutor and my name is Roland. In this video we'll be continuing with the trigonometric ratios in the Cartesian plane. If you haven't watched the previous video, please make sure to go and have a look, because it's just a quick revision on how the right-angled triangle works. Right, so let's look at this. We've got a line that starts at the origin and moves up towards a point diagonally. That point is called P, and it has the coordinates x and y. The x-axis is drawn in, and so is the y. And then we call that line, that diagonal one, R. Right, let's discuss the cast diagram next. Over here we'll understand where the angles will be negative and positive, depending on whether it's a sine, cos, or tan, and which quadrant the angle actually is in. So the sign of a trig ratio depends purely on its location on the cast diagram. So as you'll see later on in this video, you'll have sine, cos, and tan being positive and negative in different quadrants. So we'll draw this diagram first. We put 270 at the bottom, and then we'll put 0 and 360 on the right there for the x-axis. Y-axis has 90 degrees, and on the other side of the x you've got 180 degrees. So it moves from 0 from the right up to 90 anti-clockwise, then up to 180, then 270, and then 360. So we've got our quadrant 1, our quadrant 2, our quadrant 3, and quadrant 4. It's important that you remember this so that you can understand what to write when they ask something like, when the angle is in quadrant 4, what sign would the tan of theta be? And you know, okay, well, tan is not positive in quadrant 4, as you'll learn later on, and you'll just say it would be a negative angle. So now we're talking about cast. So C, A, S, and T. We have all angles representing the A in quadrant 1. Then you've got sine positive in quadrant 2. Tan is positive in quadrant 3. And cos is positive in quadrant 4. Just make good notes of this. It's very important that you get it in first time. So it's cast. C-A-S-T, so quadrant 4 for C, quadrant 1 for A, quadrant 2 for S, and quadrant 3 for T. Now let's do the reduction formulae. Reduction formulae work as follows. Take good note of this, it's very important. So I'll put it in red and nota bene. When determining the function, the values of 90 degrees plus or minus theta and theta plus or minus 90, the function will change. And we call it, it changes to its cofunction. Take good note of that. You'll see what happens when you use sine and cos. Right, let's draw our set of axes again. And let's do a little bit more explanation. Right, let's quickly number our quadrants. And let's move forward. So we have, in the fourth quadrant, we have C, A, S, and T, going from 4, 1, 2, 3. Right, so in the first quadrant, where we have the A, in blue, we say that all functions are positive. So if we have sine of 360 degrees, meaning that we're coming from the x-axis upwards towards the y-axis, but stopping before the y-axis, we say 360 degrees plus theta, or any angle like an alpha. we then say the answer is positive sine theta. The same goes for cos of 360 plus theta. We said the answer is a positive cos theta. The same works for tan. So tan of 360 plus theta is a positive tan theta. Now, if you look at it, you've got sine of 90 degrees, meaning that you're starting at the y-axis, the right-hand side, moving towards the right, but stopping before the x-axis. We say that we've got cos theta, but it's a positive cos theta. That's the change that we discussed earlier. Now you do the same for cos of 90 minus theta, because that now gives you sine of theta. So take very good note of that. There we go. Cos 90 minus theta is sine theta. Okay. So now we move to quadrant 2, where we see that sine is always positive. So here we have 180 degrees minus theta, meaning you're going from the left-hand side of the x-axis, moving upwards towards the y-axis, but stopping just before, and we say it's a positive sine theta. Now cos theta going from minus 180, so from 180 minus theta, so the same action as what we did with sine, leaves you with a negative cos theta, because cos is negative in this quadrant. Let's do tan of 180 degrees minus theta. And here we say that moving up from the x towards the y, we've got quadrant 2 and only sine is positive, so tan is a negative tan. Now once again, we do sine of 90 plus, meaning that we're going from the y-axis towards the x-axis, going leftwards, and we say it's a positive cos theta because sine would be positive in this quadrant. However, cos moving from 90 degrees towards 180 now sits in the second quadrant, and so it is negative because only sine is positive here. So we write a negative sign and we change then the cos to sine, leaving with negative sine theta. So just make note of that. You've got your sine, which is positive in the second quadrant, so therefore the cos stays positive. The cos is negative, therefore the sine becomes negative. So sine, just to make final note of it, is always positive in the second quadrant. So there's two steps, I guess you could say. Sine changes to cos, but it stays positive, so we put a no negative sign in front of the cos, and when cos changes to sine, it stays negative in this quadrant. So we've got the tangent functions that are positive in the third quadrant, between 180 degrees and 270 degrees. Tangent is always going to be positive. So let's start off with it. We've got sine of 180 degrees, meaning it's going from the x-axis towards the y-axis, downwards, but stopping before 270 degrees. We say that sine is negative here because only tan is positive. The same goes for cos. Cos from 180 plus theta is in the third quadrant, meaning that it's a negative cos theta. Tan would be 180 degrees plus theta, meaning that it stays positive as tan theta. Here we go. Sine is negative, cos is negative, and tan is positive. Now let's move to the fourth quadrant, where the cosine function is always going to be positive. The other two, being sine and tan, are always negative in the fourth quadrant. Okay, so let's start with it. We've got sine of 360 degrees minus theta, meaning it's going from the x-axis down to the y-axis, stopping before 270 degrees. Sine is negative, so we put negative sine theta there. Cos is 360 minus theta, but that's a positive cos theta. It's always good to remember this. Now let's look at tan. Tan is 360 minus theta. Tan in the fourth quadrant is always going to be negative. So we write negative tan theta. There we go, sine and tan are both negative in this fourth quadrant.